Okay, today we're going to be learning about complex numbers and imaginary numbers and doing a little assignment on that. First of all, why do we even use imaginary numbers and why do they exist? Well, if you'll do this on your calculator, try to punch in square root of -1 on your calculator. So no matter what type of calculator you have, try and punch in square root of -1. See what it does. So here's the calculator I'm using. I go square root -1, close the parenthesis, hit enter, and it says, hey, it's a non-real answer. It's always going to give you some sort of an error. It'll either say error, non-real answer, imaginary answer, something like that. Now, why is that? Well, if you think about it, what is the square root of 4? What would that be? Square root of 4 is just 2, right? Why is it 2? Well, because 2 times 2, two digits that are exactly the same, 2 is exactly the same as 2, multiply to be 4. What two digits that are exactly the same would be multiplied to be -1? There isn't any. You may be thinking, well, 1 and -1, but those aren't exactly the same. You may think, well, it's -1 and -1, but -1 times -1 is +1. So there aren't two digits that are exactly the same that multiply to be -1. Therefore, we need to call this something else that allows us to do square roots and negatives. So the square root of -1, math people have decided to call that an I, or an imaginary number. So the square root of -1 is an I. Now, this follows, though, the principles of mathematics, obviously. So when I have I squared, I actually have square root of -1 times square root of -1. Think about this. What's the square root of x times the square root of x? Or the square root of 2 times the square root of 2. What would that be? Square root of x times square root of x is x. Whatever's underneath the root just came out of the root. Square root of 2 times square root of 2 is 2. Whatever underneath the root just came out of the root. Now, same thing happens here. If I take square root of -1 times square root of -1, this is going to be -1. I is going to be I, okay, which is the square root of -1. That's what we've defined it to be. But I squared is going to be -1. That's super important as we go through these. I cubed is really just I squared times I. In other words, it's I times -1, which will be -I. I to the fourth is I squared times I squared. You'd add those exponents. That's how I get I to the fourth. I squared times I squared, -1 times -1 is going to be a negative times a negative is a +1. And you'll notice this starts repeating now every fourth one. So if I do I to the fifth, it's going to be I. All right, because I have I to the fourth, which is just 1, times I, which is I. And this will continue to repeat. So if you divide by 4 and go off the remainder, it will match these. So if the remainder is 1, it will equal I. If you divide the exponent divided by 4, remainder 1, it's going to be I. Remainder 2, it's going to be -1. Remainder 3, it's going to be -I. And remainder 0, meaning there is no remainder. Think about it. 4 goes into 4 once with no remainder. You're going to end up with 1. Now, let's just do one really quick here. Let's say I had I to the 50th. Now, how would I know what this is equivalent to? Well, I just take 50 and divide it by 4. 50 goes into 4 how many times? 1. 4 times 1 is 4. Subtract 10. 4 goes into 10 how many times? Twice. That's 8. Remainder 2. So because the remainder is 2, it will match right there, and this is equal to -1. So I to the 50th is actually just -1. And I can find any exponential value of I just by looking at this I chart and doing that. So that's the first thing you need to know. Next thing you need to know is just how to do these. So really the square root of negative 49, if you factor tree that, would be negative 1 and 49. And 49 is 7 and 7. I have a pair of 7s, I can bring that out. And then I have the square root of negative 1. Well, the square root of negative 1 is I. So therefore, the answer here is 7I. Okay, square root of 49 is 7. 7 times 7 is 49. The square root of the negative 1 is I. So anytime you have the square root of a negative value, it will come out as an I. That's super important to have in your notes. Anytime you have the square root of a negative value, it will always come out as an I. Okay, as for this one then, we're going to do the same thing. We're going to say, hey, we got negative 1 and 108. And then we're going to factor tree down the 108. Well, 2 goes into 108, half of 108. Half of 108 is 60. Let's see, what is half of 108? Better make sure 108 divided by 2, 54, sorry. 54. And then I'm going to factor tree down the 54. That's a 9 and a 6. And 9 is 3, 3. 6 is 2, 3. So I have a pair of 2's and a pair of 3's. 2 times 3 is 6. Notice this 3 is going to have to stay under there. So I'm going to have 6. I have the square root of the negative 1, I, roots of whatever's left. That's going to be my 3. So the square root of negative 108 is 6I roots of 3. The 6, because we had a pair of 2's and a pair of 3's, as we multiply those as they come out, I get 6. Square root of negative 1 came out as an I. There was a 3 left under the root, so I can't bring anything out with it. It doesn't have a pair to come out with it, so it's just square root of 3. Okay? Now, when we talk a complex number, this needs to go in your notes, a complex number is always in the form a plus or minus bi, where there's a real part, the a value, and the bi part is the imaginary part. So in this equation here, it says solve for x and y. That's what this will say on your assignment. And it'll have it written like this. All I got to do is set the real parts equal. So this 36 is a real part, and the negative 4x is a real part, and then I just solve for x. So I write 36 equals negative 4x. Again, real part equaling real part. Solve for x. Divide by negative 4. X is negative 9. Okay? Fairly simple. Same thing with the I part. So now I have negative 1 half y I equals 3I from this side. Now, what I want to do is get this y by itself. How do I get rid of the I? Well, divide by the I divided by I goes away. That leaves negative a half y equals 3. How do I get rid of the negative half? Times it by a negative 2. Think about that. A negative times a negative will be a positive. The 2's will divide down to 1. 1 times y is just y. But if I multiply this side by negative 2, I've got to multiply this side by negative 2. That will equal negative 6. So y is negative 6, x is negative 9. There'll be a few like that. Again, you set the real parts equal to each other, solve for x. Set the imaginary parts equal to each other, solve for y. When you divide out the i's, they'll always divide each other out on both sides, and you'll be able to find the value of y. All right, next, we're going to either add or subtract and then multiply these type of numbers, which are complex numbers. Adding or subtracting is very simple. You just add the real parts or subtract the real parts, and you add the imaginary parts or subtract the imaginary parts. In this case, we have a subtraction between, so I want to distribute that before I add those. That'll change the signs. In other words, this first part stays the same, negative 10 plus 3i, but the second part, negative times a negative, is a positive 11. And then a negative times a positive is a negative 5i. Now I can simply add those values. So I take negative 10 plus 11, that's 1. And 3i minus 5i, that's negative 2i. So when you add or subtract, you add the real parts, and then you add or subtract the imaginary parts. Okay, fairly simple. Now if there's no plus or minus between them, we're going to multiply. This is where you have to FOIL, and you're going to have to remember this I squared is equal to negative 1. So let's do this one. So I'm going to FOIL this out, distribute. 2 times 4 is 8. 2 times negative 5i, so I'm distributing here. 2 times negative 5i is negative 10i. Now I'm going to distribute inside of here. 3 times 4 is 12i, and then I'm going to distribute to here. 3 times negative 5 is negative 15. I times I, this is the important part. I times I is I squared. Now, I squared is negative 1. Therefore, negative 15 times negative 1 makes positive 15. Now I just add like terms. 8 plus 15. Remember to turn the I squared into a negative 1. Negative times a negative made that a positive 15. That's important for your like terms. You've got to change the I squared to a negative 1. Remember that comes from this I chart up here. I squared is negative 1. Okay, now I'm going to add those like terms. 8 plus 15 is going to give me 23. And then I'm going to have negative 10i plus 12i is positive 2i. Add the real parts, add the imaginary parts separately. Okay. Let's do one more of these. These are called imaginary conjugates. The interesting thing about this is you have an complex number and a complex number with imaginary parts. When I'm done, I won't have any imaginary number because they are conjugates. Conjugates just mean that they are exactly the same binomial, but the opposite sign between the imaginary parts. So I'm going to multiply this out. Notice the 5 times the 5 is 25. I'll get negative 30i on the outside, and on the inside I get positive 30i. Those two are like terms, and they'll add out, and I'll get rid of all my i's here. So that's the important part, is that your outside terms, when you multiply 5 to negative 6i, becomes negative 30i. But when I take 6i, positive, times a positive 5, I end up with a positive 30i. Those will add to 0. But my last terms, I still have to distribute the 6i to the negative 6i. That's negative 36, positive times a negative, and then I squared. But I squared is negative 1. Therefore, this is positive 36. Negative times a negative is a positive 36. 25 plus 36 is going to be 61. Now, what happened to the i's? These added to 0. 30i minus 30i is 0. 36 plus 25 equals 61. That's my answer. The last type is what we call a transmitter electrical box. So in a transmitter electrical box, there's going to be resistors, inductors, and capacitors. The capacitor is a negative eigenvalue, so those will be negative I values. The inductors look like this. Those are going to be positive I values. And the resistors are going to be your real number part. So they'll look like that. So it'll look like something like this, where you have this box. It looks confusing, but it's actually very simple. Pay attention to where your resistor is. The resistor is the real part. Write that part down first. That's just going to be 12. Okay, 12 ohms in resistors is just 12 in real numbers. Then your imaginary parts are going to be depending upon whether you have an inductor or a capacitor. If you have an inductor, which looks like this, you know that those ohms, those 9 ohms, are going to be positive. The inductors are positive, so that's a plus 9I. The capacitors are going to be negative. The capacitors look like this. This is going to be negative 6I. Then you just add your I values. So I end up with 9 minus 6 is 3I. My real part is just 12. There's no other real part to go with it. Don't worry about this little symbol down here. That's just the alternating current of an electrical box. But that's how that works. Okay? I want you to do page 138 in your workbook, 1 through 18. When you get to 18, it'll say, hey, I've got negative 7 minus 5I multiplied by the conjugate. Well, what's the conjugate of this? What's the conjugate of negative 7 minus 5I? I gave it away right there. It's going to be negative 7 plus 5I. Do change the value of the I part, the imaginary part, but do not change the sign of the real part when you write a conjugate. Now I'm ready to multiply that out. I'm going to take negative 7 times negative 7. Negative times a negative is a positive 49. Notice the inside and outside are going to cancel. I'm going to end up with negative 35I and positive 35I. So I'm not even going to write those down. But I do need to distribute the negative 5I to the positive 5I. Negative times a positive is a negative. 5 times 5 is 25. I times I is I squared. But remember, I squared is negative 1. Therefore, a negative times a negative is a positive 25. 49 plus 25 is 74. And that's your answer. Okay? That's how you do each of those. So go ahead and do 1 through 18, page 138 in your workbook, set 4.6. Thanks.